Happy Tuesday, everyone. I'm Lori DeToro, Communications Manager for Turntide Technologies. Thank you for joining us today to learn more about the state of hybrid and electric systems. Our planned presenter, Wilfried Alber, is not able to join us today, but we are very pleased to have Martin Weissbart, Principal in Roland Berger's Munich office and member of the firm's Transaction Investor Group, and Walter Rentzsch, Director in Roland Berger's Detroit office and a member of the Commercial Vehicle and Off-Highway team joining us today. Thank you both so much. Before we get started, we have some housekeeping tips to share. This presentation is being recorded and it will be available on demand on the Current and Wave website. We will have time after the formal presentation to answer any questions you have. Please use the Q&A section to ask your questions anytime during the webinar, and we will answer as many as possible before our time is up today. And remember, this is a live event, so when we mess up, and we probably will, laugh along with us, and we appreciate your understanding. So that is it for housekeeping, and we're ready to get started. So Walter, please take it away.
Perfect. Thank you so much, Lori. And thank you for the introduction. So as Lori mentioned, the topic for today's session is state of electric and hybrid systems. And we'll have two presenters here today. Lori already introduced us briefly, but we want to spend a few minutes just providing a little bit more background on the two of us. I'll start here on the left. Walter Rentzsch, my name. I am a director in our automotive practice based in Detroit, and I'm focused on commercial vehicles and transportations. And in that context, I've done a lot of work around powertrain technology. I worked with major commercial vehicle OEMs as well as suppliers and helped them develop their electrification and portfolio strategy. I also worked with fleets and helped them navigate the waters and the challenges of fleet electrification. Quite recently, I did a study with the American Trucking Association on what does it take to electrify all of America's medium heavy-duty trucks. Background-wise, I'm an engineer, and before joining RB, I worked in the automotive industry for a couple of years. Maybe Martin wants to say a few words.
Thank you, Walter. Martin, I'm part of the investor support practice, as Lori just mentioned, but I also have a second chair I'm sitting on. I'm also part of the off-highway team in Europe and also supporting the global team. I was historically also part of the management board of a medium-sized tier 1 supplier for powertrain components, both in construction as well as agriculture. So know the market not only from a consulting perspective, but also from the industry. I'm strongly focusing on everything around alternative propulsion types, battery electric, hybrid systems, but also most recently also on fuel cells, hydrogen, and obviously also HVO.
Yeah, perfect. Thank you, Martin. And now, being good consultants, we have to make a little bit of an advertising here. Not sure if everyone is familiar with the company Roland Berger. We are basically a global management consulting firm. We have a very strong presence in Europe, but we're also in Asia and very fast growing in the North American market, in particular in the industrials and regulated infrastructure space. We have many clients globally in the commercial vehicle and logistics arena. We work with major off-highway OEMs as well as suppliers to all the different OEMs, be it CV, light vehicle, or off-highway OEMs. And we have a broad range of offerings from strategic advisory to very operational support topics down to investor support, where Martin is working mainly. And I think that's enough of advertising. Now let's go into the content. So for today's discussion, we brought three topics. First one, we want to talk a little bit about electrification challenges and opportunities in the light vehicle and commercial vehicle space. Why? Because we think this segment is more advanced than what we see in off-highway, and we can probably derive some learnings here from that segment and then translate them to off-highway. And I'll cover this first piece here around probably 15-20 minutes. And then the second piece, Martin will take us through this. There we dive deeper into the status of electrification in off-highway. And here also in particular look at the role of hybridization. And then we have time at the end, probably 20 minutes or so, that is reserved for Q&A and for an open discussion. So with that, we'll go into the content, and I'll start with the first section, the electrification challenges and opportunities in light vehicle and CV. So what we have seen in the past is that market expectations for electric vehicles have really followed a typical hype cycle over the past years. What you see here on this chart is the S&P 500 EV index, which basically tracks the performance of the 50 top largest companies in the EV industry. And 2 years ago, the market was at its peak, at the peak of the electrification hype. Everyone talked about inflated evaluations, demand projections were high, and optimism was at its best. And then starting in late 2022, market expectations for electrification began to temper. And they are now leveling down and stabilizing at a more moderate level. This growing uncertainty in the market has increased pressure on industry players across all segments, be it OEMs or suppliers. And as a result, investment payback periods have been extended and portfolios have been fragmented more and more. So looking back in 23, back then, the industry saw very strong growth rates over the past years. Between 2019 and 2022, year-on-year growth rates north of 50%, and everyone was highly optimistic. And forecasts back then were also very optimistic. Back in 23, projections, for example, from S&P for 2030 were almost 50% electrification rate in the global light vehicle space. The sector was booming. The only concern really was around potential bottlenecks like capital, equipment, raw material, resources, and time constraints. And all the OEMs were committed, and we also saw that regulation came in place supporting this fast growth. Now, we now are in 2025, and we witnessed over the last 2 years a slowdown in growth aspirations. The expansion of the electric light vehicle market has decelerated. We are now down to something like 12% growth rates, and market signals have weakened. So we see Chinese price competition intensifying. Many OEMs are increasing losses on their electrification programs, and some have even began to cancel or at least delay their EV programs. And additionally, just this week, the new US government announced policy changes that will scale back the EV incentives and regulations, which will then have a further negative impact on the growth outlook for electric vehicles. So as a result, the projected 2030 electrification rate has been revised downward from nearly 50% a couple of years ago to 34%. But of course, we have to keep in mind that 34% electrification rate over a 15-year time frame is still a very significant accomplishment. So we still believe that progress continues and that electrification is coming. It's just not coming at the pace that we maybe anticipated in early 2020s. What we are seeing is that all market participants are seeing headwinds. So starting on the supplier side, especially the cell manufacturers, they are under pressure because their profits are lower than expected. The OEMs, they made significant investments in the electrification programs, and now timelines and volumes are being pushed out. And on the customer side, we see waning interest. People are pushing back targets and questioning whether the commitments that they have made on the sustainability side, they would really stick onto them, or if they should modify them. So with all this together, the question then is, what is the impact on the supplier landscape? And we have a standard framework that we use across industries, and we applied it here for the automotive context. And I can basically walk you through it real quick. It's basically, we call it the winners framework. It looks at companies within a specific sector, in this sector, automotive players, but broken down into different domains. And we look at their invested capital growth and their 5-year average profit. And then they fall into different buckets. They could either be winners, they could be cash generators, underperformers, or profitless growers. What we have seen over the past 5 years is that suppliers, especially the powertrain suppliers, have faced immense pressure. They're all somewhere in the underperformer or maybe profitless grower quadrants of the matrix. And yes, of course, there was inflation and labor shortages was an issue over the past years, and that for sure played a significant role here. But the fragmentation of the supplier portfolio, together with the uncertainty of EV sales ramp up, I think has been another critical factor impacting supplier performance here. And this, of course, doesn't get unnoticed. This also impacts supplier valuation. That's something that you're seeing on this slide here. So historically, powertrain suppliers with diversified portfolios, and that's the blue players at the top. So they covered for both ICE and EV markets at the same time. Historically, these guys had a higher valuation than the powertrain players with ICE only portfolios at the bottom with the gray line. Now, what has happened is that since the hype cooled down, the gap between the two lines is closing, and to a certain extent, sometimes even the powertrain players with ICE-focused portfolio are performing better than the ones with a diversified portfolio. Now, what does this all mean for CV and OH? Basically, when you look at success in the CV or OH space, it really boils down to what I would call a simple equation. You need the right product, you need the right infrastructure, and you need to have competitive total cost of ownership. And keep in mind that this here really is a multiplication. So if one of these factors is 0, then the total output of the equation is 0. So if the product cannot perform, it doesn't do what it promises, or if the infrastructure isn't ready, or if the economics don't work and there's no TCO benefit and driving an electric truck costs more than driving a diesel truck, then the whole thing falls apart and electrification stalls. So solving this holy grail challenge can only be done in an ecosystem approach. And the plan is now to go quickly through each of these elements and see where do we stand. Have we solved these individual factors already, or are there still items open? Starting maybe with product, the first one. So this is, I know, a very busy chart, but I'll try to slowly explain it. What it shows is it looks at different medium and heavy duty use cases. So you have 3 heavy duty and 4 medium duty use cases for the US. And we've shown the daily range that these vehicles typically drive in these different buckets. So what percentage of that fleet drives, let's say, 200 miles per day to 50, 300 miles and so on. You can see that at the bottom, the medium duty return to base vehicles that typically drive less than 150 miles. And then once you get into heavy duty, they drive longer distances. And then, of course, the long haul trucks, half of them drive more than 400 miles per day. What we've done is we looked up the existing electric vehicles that are out there commercially available and pulled their range, put in some safety buffer, but then basically mapped their electric driving range against the requirements from the use cases. What you can see is that for many of the lower medium duty use cases, the vehicles that are out there, they can already do what is required. They can already cover most of these use cases. Only when you move up that chart, when you go into heavy duty, into drayage and distribution tractors, there is a good portion of the overall use case that cannot be covered with today's technology. But still, a good portion of the fleet can already be electrified with today's vehicle out there. So in the first equation, first factor in our equation, I think we can make a tick mark next to it. That one has been solved, and the remaining pieces will be resolved pretty soon. Now, the second part of the equation was infrastructure. And there's two aspects to it. One is the long lead time of installing infrastructure in a depot, for example. These here are results from a survey done by our friends at the American Trucking Association. They surveyed their members. How long does it take to put in a charging station in your depot? And the interesting finding is that 80% of the fleets report lead times for over a year. A third report lead times of even over 3 years. So they have trucks sitting in their depots, they can't charge them because they need to wait 2 years before they get the charger. And the problem quite often is that the incremental load that these depots require is so high that you need to have grid upgrades. You need to have, in some cases, even a dedicated substation just for that specific depot. And that's a lengthy process. You need to go through the permitting process and the construction process, and it costs money to put that in. So that can cause long delays in putting in charging infrastructure. The other piece besides time is money. So putting in an electric charging infrastructure system costs a lot of money. And we have done a study together with the ATA, the American Trucking Association, and estimated what would it need if you electrify all medium heavy duty trucks in the US. I agree this is sort of a bookend scenario because you wouldn't overnight electrify all trucks, but it just visualizes what is required to completely switch to electric. And the sum was enormous. We estimated $600 billion for the charging network, almost $400 billion for the grid upgrades, and that gave us almost $1 trillion investment in charging infrastructure. Now, that sounds like a massive number, but keep in mind that this doesn't have to happen overnight. This can happen in phases, and luckily there's already progress underway. There's charging corridors that are being planned and being put in, and people focus on areas where investing money makes most sense. But however, I think the key takeaway for me here is that infrastructure development will be a key factor that determines the speed of electrification in the commercial vehicle space. And then the third element was TCO, and here my biggest concern is that the prices of the vehicles are still very, very high. And without substantial reduction of EV prices, I don't see positive TCO scenarios for many use cases anytime soon. I know that OEMs are looking at ways to absorb these high upfront costs and maybe bake them into pay-per-use models, but still, without cost coming down, the TCO case will be very challenged for quite a while going on. If you take this all together, all these challenges that we saw here, I think it's not surprising that the electrification rates that we see in the commercial vehicle space, we have here a few for key truck manufacturers in Europe and North America, and then some in China. It's not surprising that these numbers are low. China is a little bit better, but still they are single digit. So, but we must also consider that the timeline to get here is limited. We've done this in 7 to 10 years or so, while ICE technology had something like 130 years to get there. So I think everything has cooled down. Everyone is looking at more realistic data and numbers, and expectations are getting more realistic. But one key missing piece is regulation, because regulation will play a crucial role in sustaining momentum for electrification. In Europe and China, I don't expect any change in enforcement and shifting timelines. I think here we'll continue as is with ambitious plans. The key question for me is what will happen in the North American market. I mean, given the most recent announcement of the new government to roll back incentives and relax emission regulations, that will for sure have a impact on electrification rates in the US. And then if that's in place, then it's really down to TCO, can certain use cases pull enough electrification interest through TCO, or are the fleet operators willing to invest in electrification rates, even if they're in electrification, even if they're not forced by the regulator. But that's all to be seen in coming years. I think this was the piece on light vehicle and CV, and the next part would then go look at off-highway electrification, and Martin would take over.
Thank you, Walter. And I think a lot of elements which Walter touched base in the CV space, we will see in the off-highway space as well, which have different states at the moment, but they will have a significant impact similar to the commercial vehicle. So we're talking about infrastructure, we're talking about TCO, and we're talking about use case as well as the OEM push, which is very much required in order to also push electrification into the market. When we look at the off-highway space, there are two driving forces, how we always look at it on the next page. On the one hand, it's the internal, on the other hand, it's the external forces we need to have in consideration. Right, so regulation, similar to commercial vehicles, similar what we saw in passenger cars, play a key role. Right, if it's in Europe, the C40 regulation, if it's for smaller agriculture vehicles, the CARB regulation in the US. There are regulation pushes in material handling, which we also need to keep in consideration, which is already further up in electrification. If we talk about aerial working platforms and forklifts, it's even the indoor emission regulation, which really pushes electrification into the game, and decarbonization, right? So when we talk about electrification historically, we now see a shift of mindset of all the OEMs and the suppliers towards talking about decarbonization, because it's far more than just electrification. On the internal side, obviously TCO will be a key point, and that not only is based on the vehicle costs, but also the operational costs, the maintenance costs. So electricity prices in the various regions will drive significant TCO next to penalties, regulation pushes from the government. And obviously the improved operation experiences, these are things that will drive further the demand from the end customer, which definitely needs to be fostered going forward as well. If we go on the next page, and I just already teased a little bit, I teased a little bit on the next, that decarbonization is more than just battery electric. You see it on the right-hand side. I think, yes, battery electric vehicle as well as renewable diesel is mentioned the most if we're talking about what key players see in the market as powertrain technology relevance going forward. But fuel cell, hydrogen, renewable natural gas a little bit further ahead. The picture basically tells you there will be a mix of powertrain solutions depending on the use cases. And I think this is something very important the OEMs stronger focusing on. If it's a Caterpillar, if it's a Komatsu, the use case really defines what propulsion type is necessary. What are the concerns that are hindering a little bit of the push? Right. On the one hand, it's obviously the current down cycle of agriculture construction machinery, which we see also continuing in 25, especially in Europe. Agriculture and construction will most likely minimum move sideways. So we see an increase in the market rather coming in 26. Key points that are current concerns in the industry that needs to be tackled are, on the one hand, acquisition costs, as I just mentioned, but also infrastructure. And infrastructure, it's not the depot charging, if you talk about construction machinery, you're talking a lot about rental companies. In agriculture, you talk about farm infrastructures where you could use similar infrastructure charge points as you have in commercial vehicles and passenger cars. But you also need to integrate mobile solutions in remote areas where construction, where also mining plays a key role. And the integration of the system. These are the key challenges OEMs as well as the end customer are facing that currently put a little bit of a brake of the rollout of electrification. If you go to the next page, what we looked at is in the different regions, where does TCO make sense? On what timeline does it make sense, right? So we're currently seeing already smaller wheel loaders, telehandlers that are already TCO positive in China. We see mini excavators will lead the way of electrification. This is both in Europe as well as in the US, but the TCO positiveness mostly will come in the early 30s, in the mid 30s even. And then on mining trucks, yes, there are pilots out there, but the TCO positivity also is strongly driven by regulation. So we see here, for example, in Australia, there's a very good environment for TCO positive for mining trucks or ratchet haul trucks already coming in the early 30s. When we go further, you see, and as I mentioned, decarbonization is more than electrification. Electrification makes absolutely sense in lower horsepower classes, and we see that already on the next page. The current penetration focuses, or the current development focuses on lower horsepower vehicles, mini excavators I just mentioned, wheel loaders below 80 horsepower, aerial working platforms here on the next page, Walter. But the larger vehicles with the larger horsepower requirements, they need the requirement of other alternatives, right? And the broader spectrum of powertrain solutions that help not only the operability, but also to cater to the use cases they're operating in. If you go on the next slide, we see off-highway, obviously the production volumes per se are significantly lower when you compare it to 75 million passenger cars, 50 million light commercial vehicle, trucks around 3 million, right? So there's a significant lower production volume in off-highway equipment, but they're not standalone. They can learn, and they are currently leveraging a lot and will continue to leverage a lot the learnings out of passenger car as well as commercial vehicle technologies, which can be catered to various application areas, as you see here, depending on the battery capacity, depending on the equipment sizes. We see the leverage, obviously, from various other verticals where we currently see an upswing or already a strong penetration of electrification, as well as other propulsion types. On the next page, what makes off-highway so complex? The complexity comes from the product modes on the one hand, as well as the powertrain alternatives. So for an OEM, it becomes increasingly difficult to define an engine strategy based on the entire portfolio they're serving. So that's why it needs to be a careful strategy on decarbonization, a prioritization, what needs and what can be converted from a classical ICE solution towards a decarbonized solution on a propulsion type. And these are the topics that all the OEMs we are serving, all the discussions we are driving are currently faced, and all the OEMs are facing those issues, as I mentioned, in conjunction with a downturn in the market, right? So you're facing challenges in your base business, and you need to cater to the future modes with a significant complex product portfolio. When we go further, what we're seeing, what we're currently also discussing with leading OEMs across the world is that electrification will play a key role in decarbonization, but the pace will slow down. We saw significant and very strong ambitious targets of major OEMs where electrification goes for their compact ranges, where they want to move going forward. And we saw that similar in the passenger car and in the trucking space. OEMs are stepping a little bit back and really re-evaluating what is the right strategy to decarbonize and not decarbonization at all means. And I think this is very important, that it becomes more cautious, but it will remain in the portfolio what is required in order to decarbonize the portfolio. Currently, what you're seeing, there's a lack of valid solutions. So the infrastructure is not ready yet. The TCO is not met yet. But we see bridging technologies, and we will continue to see bridging technologies. I'm very excited in 3 months being at Bauma again, where the new trends are going towards. We will also see a delay, as I mentioned, in electrification. And we really see that the OEMs are currently tackling market conditions, will position for market conditions, and the new platforms will include a large variety of propulsion solutions. If we go to the next page, as bridging technology, as just mentioned, hybrid solutions are widely spread and will continue to be integrated into the systems. And this has various aspects, right? So it will be integrated in the drivetrain, for example. So you have an e-engine integration within the ICE powertrain, motion systems, but also auxiliary systems where we see a lot of electrification. If it's, for example, a swing drive, an oil pump, HVAC systems, where we see more use cases for electrification to reduce emission as well as petrol consumption, right, or diesel consumption. And this is not only a number we see on the next page. It doesn't stop at certain applications. It doesn't stop in certain verticals. It is across the board, right? So in agriculture, for example, we always distinct in two environments or two ecosystems. You have the field and you have the farm ecosystem. On the field ecosystem, we see a longer time towards a positive TCO model for decarbonization. You will see tractor combine decarbonization. We made a study on combine electrification. It would require a 4-ton trailer for just the battery. So there you need different means of decarbonization. On the farm ecosystem, on the other hand, where you have telehandlers, where you have a homogeneous driving pattern, where you have a use case of around 4 hours of each machine, right? For the wheel loader, telehandler, and various other aspects, this can be electrified quicker and the TCO will play out earlier. If we go to the next page, it not only doesn't stop at all the verticals, you also see that all the key manufacturers and key OEMs are actually serving to this needs, right? So they're driving actually the trend using hybrid solutions as bridging technology, but also as opportunity. And we will see that in a second, that some OEMs even use it as in order to drive catering to the use cases that are required. Who is currently driving the most in that forefront? And we see on the next page, there are 4 key players in the market who lead the hybridization. So it's Caterpillar, and we mapped here the volume of the patents that are related from 2000, so over the last 2 decades. And you see a significant push from Caterpillar, Komatsu, Hitachi, as well as Volvo, right, which serve from compact machinery to mining a large front of products And those are the ones who also see the need and drive the need of the decarbonization across various propulsion types. Taking the example from Caterpillar, they are using hybridization to cater to the broad use cases of their end customers, right? On the next page. So hybridization makes sense, because you have a various user profile, high energy consumption in various segments. So they're using as a modular approach on their architecture and boost sustainability, even so you are not there on the development on other propulsion solutions. Komatsu, on the other hand, on the next page, they're really driving hybridization as a stepping stone and using it to learn, to push the customers to understand the ecosystem and pushing it towards a fully electrified portfolio. So there are different methodologies, different beliefs of OEMs, but they all go in the same direction. So it needs to be cater to TCO positivity, it needs to cater to the various use cases, and also takes in consideration that the product variety and the complexity of your entire portfolio needs to be prioritized and cater to the decarbonization. What do we expect in 25 and beyond? So there will be a coexistence of hybrid and full electric offerings. So there will be even a more complex portfolio of engine offerings. HVO will play a key role for decarbonization in the short term. Electrification in the compact machinery is something that will drive going forward, especially in Europe and in Americas, in the mini excavators and the smaller wheel loader segment. There will be a significant investment in the ecosystem. So there will be technologies around in the fleet systems, the battery management. So the entire ecosystem will evolve and can learn and will learn from other segments as explained earlier. And there will be a strong collaboration across industries. And I think this will lead now to our third section and opening up the question both on the commercial vehicle side as well as on the off-highway side.
Excellent. Thank you both so much. We are going to get started with our first question. So what opportunities do you see for hybrids in the commercial vehicle space?
This may be a question that I can answer because I covered the CV side of things, but basically the way we see it, and hybrids in the commercial vehicle space have been around for quite a while. I mean, if you go back 10, 15 years or so, there have been lots of tests out there and data has been collected and lots of work has been done around it. But and then it sort of disappeared and everyone started to talk about electrification. I think we now, with the new government, we might end up in a situation where EV mandates and targets and regulations get pushed out, timelines get delayed, and fleets still have their own sustainability targets. So assuming that not everyone now throws everything overboard, but the big fleets, the JB Hunts, the Coca-Colas, and so on, the private and for hire fleets, they would, or a good chunk of them would stick to their commitments. We could be in a situation where there's no regulatory push, but still fleets want to do something. And they will look at these fleets, they will look at multiple levers to reduce emissions. And it could include anything like biofuels, it could also include hybrids. And they will make decisions on a case-by-case basis. How much does it cost me to use biofuels on a certain use case? How much does it cost me to use hybrids on a certain use case? And then based on that, they will pick different technologies. So that, I think, opens up the opportunity for hybrid trucks. People want to do something, but they don't want to go the full way down to full electric. And past tests on hybrid trucks, they have shown that you can get some fuel savings, but they were not enormous, and it was difficult to get to positive TCO cases. But keep in mind that these vehicles, they also have other benefits, namely they can run full electric for certain ranges. So in Sweden, Scania, for example, is testing an electric medium-duty truck that drives electric once it enters an inner city zone, and then it delivers things overnight quietly and without emissions. And once it's out of the inner city zone, then it drives traditionally with an ICE back to the warehouse. And I could imagine similar solutions here in the US, where a drayage truck drives on a normal combustion engine, but once it reaches a no emission zone near a harbor, then it switches to electric. So I think in this world of different powertrains that we're probably going to enter, hybrids will play a role, and they will target very specific use cases.
Great. Our next question is, what do you see as far as the demand for charging solutions and infrastructure for CVOH?
I mean,
Martin, do
I
you
maybe
want
can start. You know, I'm
Yeah.
currently actually, I'm currently also working closely. So I'm currently actually doing 3 projects on commercial vehicle charging. So Germany is also one of the specific markets where we have even tenders on en route. So these are already, because we are a transit market, and in Central Europe we have a lot of transit markets who are currently pushing a lot on, similar to passenger cars, en route charging opportunities. We also projected until 2040 you still have the strongest demand for energy in charging solutions will be depot, as also mentioned by Walter earlier. So depot as well as hub structures, and hub means, you know, when you're at a harbor picking up, or if you pick up at a customer, you need to recharge. Those will be the leading use cases where you have charging. So there will be a significant need on investments in infrastructure on the trucking side. On the off-highway side, and maybe I pause there and Walter can expand a little bit more on that highway.
Yeah, I can jump in here. What you see on this slide is, and I maybe glanced over it too quickly earlier on. This is a result from the analysis that we did together with the American Trucking Association. And as I said, it's sort of the bookend scenario. We electrify everything, 100% of the medium heavy duty trucks. Everything gets electric. What do I need in terms of infrastructure? So it's an extreme picture, but I think you can still derive some learnings. And we basically broke out things into what we call a local charging network. The first bucket that could either be in a depot or en route. So yeah, but it's still close to where the fleets operate. And then you have the highway charging network, which is typically en route. And the interesting piece was that actually the local charging network was the investment need here is higher than the highway charging network. And the reason is that you have, and it is driven mainly by the level 3 on-site charging, the 333 and the $69 billion. And that is because you have these heavy duty regional trucks, distribution trucks. They don't have a lot of time to recharge. They need very powerful chargers. And they need to, get a lot of electricity in a very short time frame. The charger itself is not crazy expensive. I mean, for sure, it's expensive, more expensive than the level 2 charger. But the make-ready investments and the grid upgrades, that's what makes this expensive. And then you have the charging network side. There is still some investment on building out the highway network, and you need to also improve the grid around it. But the good thing is you don't need to start with every piece that's on here. You can start with smaller vans, distribution vans, postal distribution vans that can live on a level 2 on-site charger. Then you slowly get into level 3 charging, and you don't need to spend this amount of money on day one. If that answers the question.
There's another
Should I comment on off-highway as well?
Oh, yes, please do.
So on the off-highway side, as mentioned earlier, the infrastructure also follows the diversity of the product portfolio, right? So you have a lot of use cases that are not able, a depot like, and on a farm, for example, yes, you can have a wall box and the AC, like 50 kilowatt DC charger will be enough. Right? Sometimes even the AC charger, because as I mentioned, the using profile is around four hours for a small wheel loader, for a small telehandler, which is mostly used on farms. On the larger, and then if you go to construction sites, there are a lot of remote construction sites. So we see a lot of trends currently towards mobile solutions for charging, in combination with battery storage solutions. We are a lot of in discussions around battery storage solutions, mobile solutions. They're in the early stage. I think that's why that also hinders a little bit the role of electrification. In handheld devices, we see a lot of electrification in material handling, because they have the opportunities for the charging or in handheld battery swapping. For mobile solutions, if it's a highway construction site, inner city construction site, where you don't have the access to the grid, where you don't have a permanent charger, you need those mobile solutions. A lot of OEMs are working on those in partnerships or even develop it themselves, right? If you look at JCB, if you look at Wacker Neuson, if you look even at the large players, Komatsu, you saw all of them at the Bauma. It needs, and this is where you need to offer a turnkey solution, not only the vehicle, and Walter mentioned that earlier, if you buy the vehicle, it doesn't stop there. If we're in the example what he mentioned with the trucking, when you need to wait 3 years for your charger and you don't need to use the truck, then obviously that the use case makes no sense, right? So you need the infrastructure, you need the availability of the infrastructure that caters to the use case, and then you can electrify the vehicles.
And by the way, thank you, everyone. We have so many questions. We may need to do a Q&A blog and let you guys answer some offline, but we'll get to as many as we can. The next one is looking at CE electrification trends. How do you anticipate the trends of low voltage versus high voltage designs progressing in the next 2 to 5 years?
I think it's it's part of the architecture. You're absolutely right. I think we rather look at from the kilowatt hour, the horsepower requirements of the vehicle, right? So I think the compact machinery, and then you obviously have the correlation between AC and DC, or low voltage, high voltage. I think the use case could cater to an AC solution for the charging, right? And the architecture obviously depends on the usage of the vehicle, right? So if it's a high power requirement, obviously you have different architecture of the vehicle. But from a charging, as I mentioned, you often have a usage between 4 to 6 hours on a construction site, right? Not constantly working. The same on a farm. Low voltage is fully fine because you have enough time for the charging.
Okay. What further component technology developments are necessary to enable larger off-road machines to transition to full electric? If that's something you can answer, or we can let you think about that.
Can you repeat the question? Sorry.
Sure. What further component technology developments are necessary to allow larger off-road machines to transition to full electric?
I think it will never, the issue will not be the battery sizes, right? It's just the use case allowance. I think it's the TCO discussion we need to have on the larger equipment. as I mentioned, look at the combine, right? High horsepower requirements. You would need a 4-ton trailer on the field, but just for the battery. So I think the horsepower requirements, auxiliary drive, fully understood. In mining trucks, you have a lot of recuperation modules that help already electrifying certain modules. I think it's the architecture that also needs to be completely newly developed. But so that's why the larger machinery before the 40s, we don't really see a massive shift towards electrification. We see other decarbonization needs, right? And that's what we wanted to make sure. There are fuel cell discussions. If you saw, for example, the H2 pilot from Volvo on the articulated dump truck, you see fuel cell solutions in regitor trucks. Yes, you have, and we showed that TCO positiveness in Australia on mining trucks. But this is something needs to be carefully watched. Where's the volume and where does it make sense from a TCO perspective?
Okay. The next question is, from a customer perspective, have you had the opportunity to look into their desire for adoption of hybrid electric heavy mining equipment? If so, has there been feedback about concerns regarding adoption?
I mean, hybrid solutions, as I meant, right? So auxiliary drives, we see a lot of examples already. Motion drives, sorry, my laptop is running low. Yes, you will see hybridization, and the customer definitely wants to reduce fuel costs, right? You saw that American Mining, they published, a mining truck. I think it was 1 million liters of diesel a year, right? So the reduction of emission, the reduction of fuel consumption will play a massive role, and hybridization can already help to go the path of decarbonization. So yes, there is a strong customer demand, but it will start with the auxiliary drives, with the motion drives, as we mentioned, and then moves on. I think recuperation is already, especially in mining, is already a valid solution that could save a lot of fuel.
Great. What is the greatest cause of battery electric vehicle uptake? Product, infrastructure, or total cost of ownership?
I would say products. I think it's that problem has been solved. I'm more concerned, and cost of ownership. I think we'll find, or the industry will find solutions around it. Innovative financing models where I mentioned it. Pay-per-use models where all the risk of the upfront investment and also the risk of the residual value gets absorbed by the OEM. That's all possible, I think. The biggest challenge that I still see is the charging infrastructure build out. It's just a big demand, and it's a big job. It needs a lot of investment. A lot of people have to work together, and it's people who historically have not worked together, right? It's the fleets, it's the OEMs, it's the utilities. They historically don't sit together on the same table, and now they have to solve this problem jointly. I think this will ultimately determine the speed of the electrification, how fast that can be solved. And as I said, when we calculated, it's an enormous amount of money that it needs to be put in, but you can start small. You can start with local distribution and do a lot of good stuff already by electrifying these Amazon depots or whatever distribution depots before you even think about this electrifying heavier duty long haul or regional haul and long haul distribution.
So, next question, and it may be a mix of both, but the data that you shared for the electric future, was that for the USA or the world as a whole?
That was largely world as a whole. So what I showed at the beginning, where we had we had a good, and I can go back to the slide. We had this good uptake and penetration rates here. that was all global. And then later on, we had, when we talked about numbers here, the progress of the different OEMs, that was very specific commercial vehicle in Europe and North America and China.
Okay. So A, as far as market quantities and timing, as well as B, technology and solutions, CCS, MCS, or is there a need for something new or better? If that all makes sense to you guys.
Sorry, can you say that again?
Sure. A, as far as market quantities and timing, as well as B, technology and solutions, CCS, MCS, or is there a need for something new or better?
I mean, in trucking, in Europe, we see currently, obviously, the Selm Albitronic 400 kilowatt CCS chargers, right? So it's the same technology as in passenger cars. Yes, and we have in the German tender, by the way, also the megawatt chargers, but they are currently in piloting stage. I think megawatt charger will play a role, right, in the mix. But currently, from a timing perspective, CCS is something what we see currently in the rollout. In the depots, it doesn't need to be HPC chargers, right? So we see there also, as I mentioned, a mix between DC, sometimes even AC chargers, right? Depending on the use case. And I think that is very important to understand. I think the homogeneous driving patterns, which Walter also showed, right, where lower distances also traveled per day, those ones already can be catered by electrification on route. And I think that is something where you don't need to change the technology, and that also even helps to speed up the technology, right?
Great. Let me grab the next question. Do you see any specific, and this may be our last one, do you see any specific enabling technology trends in the near to medium term?
Enabling technology in what sense?
I think just for the move or adoption toward electric or hybrid, are there any technologies that you see that would help spur that forward?
I think
I mean,
the biggest trend is commercial vehicles. If I look from Europe, right, the commercial vehicle electrification, there's a lot of pull from players like a Coca-Cola, like a Carrefour, who want to decarbonize their fleet, right? And so I wouldn't see a technology, because you can use the technology, as I just mentioned, from a charging infrastructure perspective. You could, it's out there. The same technologies the OEMs and the trucking also offering. I think it's the infrastructure investments which you need if you fuller want to explore and exploit the electrification of the entire fleet, because there are a large magnitude of use cases of the vehicles, which was shown on the matrix, and only a smaller portion, if you go on a longer distance, can be catered with the current technology, with the current solutions in the market. With the new platforms coming out, with the new developments, we will see range extensions, and we will also see a larger catering to all the use cases that are required.
Yeah. And maybe just one additional comment. I mean, for sure, there need to be sort of telematic enabled services and solutions. Like you need to know what the range is, where can fuel, what is the state of charge and health of the battery. I think all these add-on services, they need to be available, and route planning, of course, need to be available and working.
In Europe, you need pre-booking systems. So I think we will see different usage of the infrastructure, right? Where in passenger cars, you charge, the charge point operator has a high utilization traffic risk. In trucking, we will see far more bay reservations, you have charging on a day, but overnight, you are in Europe, you have regulations on, after 4.5 hours driving, you need to stop for 45 minutes. Obviously, then fleet management system with the pre-booking systems will enable to more efficiently use the time where you need to stop. You can recharge, you can do routing systems. So that I see as a key topic. The second thing I think where I see the most significant investment, and that will be globally, is the grid. The grid stability on at all means, right? And we will see that we electrify buses, we electrify trucks, we electrify off-highway, we electrify passenger cars. I think the grid stability will play a key role, and the development and the pace of grid stability will play a key role also in the rollouts.
Well, I appreciate y'all so much. That is all the time we have for today. Thanks again, Walter and Martin, for this very engaging presentation. We thank you, attendees, for joining us as well. This webinar will be available on demand in about 48 hours. We hope you'll join us for our February webinar, Safer Battery Solutions, How to Comply with New Regulations. You can register for that on the Current Wave website. And we thank you again so much for joining us and hope you have a great week. Thank you again, presenters.
Thank you. Pleasure.
Thank you so much.